Yeah, so I run my own ML consultancy, but really I'd like to just jump into the talk if that's okay.
Did you just turn off your camera? Because we can't see you right now.
Oh, okay, let's see. Okay,
Yeah,
how's that?
great, great. Yeah.
Okay. Yeah, let me know if I'm ready to go.
Yeah, you're welcome to start.
Great. Well, thanks everyone for coming to my talk. I'll be talking about why news is hard. Uh, so I always like to start these talks with a abstract or executive summary. So here's kind of the thesis of this talk. Timely and relevant news is key for businesses and people to stay informed. There are similarities with search, but you can do a lot better by actually modeling the news process and the time components there. So I'll just give a little background about the problem I was having with my company. So I need to keep up with news to run my business. There's a lot of stuff that have happened this year. It's just critically important to be on top of, for example, what's happening with grants for businesses for relief fund, for example, or changes to regulations around, data privacy, for example, is changing. And so are regulations around using data in the context of like consumer lending. So you need to stay on top of that. I have about 500 different news feeds that I have to check. They generally are updated every single day. Some of them are small, so just one thing a day. Sometimes there's up to 10, generally speaking. Sometimes these feeds contain related or identical content. Sometimes they're different. Sometimes some feeds are a little bit ahead of other ones. So how do we deal with all this stuff? So kind of a natural place to start is saying, well, it's like building a search engine. Ideally, we just take all of these things, stuff them into Solr and call it good. So we end up with thousands of documents, they contain text, and we want some way to get out the relevant items every day. That doesn't necessarily work that well. So it ends up being harder than search for a couple reasons. And so here's a piece of news that came in that I found amusing. So National Taco Day 2020, which was a couple weeks ago, how to get food and deals from Taco Bell on the border, Surf Taco and more. So I got this news one day late, and it is not helpful one day late. You can't get free tacos the day after National Taco Day. So I would phrase that kind of characteristic is like relevancy decay. Just over time, these things are less and less relevant. And unlike search, you really have one chance to get this right. So it's a one-shot problem. That item will come in, either you present it or you don't. There's no chance to fix it later. Another way that news is a lot different from search, or at least in the context of the system that I built, is there aren't search terms. There's no one going in and typing in taco so that the system can know that tacos are what people want. And similarly, there's no citation graph. So in search, like Google is very famous with their PageRank algorithm of looking at the links within documents and then using them to figure out which ones are the most relevant. You have none of that in news. For one reason, news always goes forwards in time. So old news can't link to new news, right? So citation graph doesn't work. So that's kind of why news is harder than search, which would go back to my title. So then what can we do? We can't just say we're not going to even try. So instead, we're going to use click models. So this is a picture of the click models for web search book that I was introduced to when I was working in ad tech. We colloquially call it the Russian click models book because Yandex released some reference implementations of it. And it is an entire book focused around how do we model the probability of a click given different covariates. And it is a nice thin book, all killer, no filler. Highly recommend it. So then can we say are clicks a proxy for relevant items? So there's pros and cons to that. So on the pros side, clicks are easy to record. So you just need to wrap the click in the web browser, and then you've got that extra bit of data. I would say that they're necessary for being, a click would be a necessary condition for a relevant item, in that if there were a news item and it's never viewed ever, then it's not relevant kind of by definition. And finally, they're also objective. So either someone clicked on a item or they didn't. But then there are some drawbacks also. So some of the cons are the click occurs before the view, before the reader actually can assess whether it's relevant or not. So it's going to be shaped much more by like the headline or the source of it than, you know, the actual content of the article. I would also argue that a click is not sufficient for that reason. So just because you do a click does not logically imply that it's relevant. And finally, they're in the recommender system space called implicit feedback. So this is just either it happened or not. It's not like an actual 5-star scale rating of the news. So I'm gonna jump ahead to the architecture for the system I ended up designing. Just so you all have kind of a high level view of how this stuff is supposed to work. So on the left-hand side, we have the news coming in from a bunch of different feeds that goes through a process that aggregates all of it, puts it into a data store. That data store then periodically throughout the day will score those items and then push them into an output feed. And then we've introduced a feedback loop by putting click tracking in there. And then there's, you know, on top of that feedback, we can train a model that the scoring process can use. So very, very kind of standard architecture for these kind of recommender or search or systems. So a couple, 3 parts. And each of these parts I would also call out kind of maps directly onto the mathematical idea of a click model. So we have our X's, the actual news items coming in. We have clicks, which would be an outcome variable, a Y, and then we have a model, which is kind of a collection of parameters. So you see those notated as theta. So cool. So I'm going to talk about the actual model at this point because it's kind of the most interesting. So I call this the Neal News Design Matrix. Like, what are the actual features that we're using in order to model relevancy? So there's kind of 3 general categories. There's content, time, and position. For content, we're using something I call a double word embedding to snip it. Then for time, we have the weekly news cycle effects and annual trend. And then finally, we have some position effects related to the presentation of the items. So we'll run through each of those real quick. So the double word to sentence embedding is something I came up with. So what we're going to do is start with the document snippet. So because we're focusing on clicks, we know that the actual content of the document doesn't affect whether people actually click or not. All they're seeing is this little headline that, you know, the Gundam is not a transformer, and then a sentence of text and an image. We're not seeing the full body of the article that explains why someone in Japan would build a 60-foot tall walking robot. I mean, the answer there is clearly that it's awesome. So we're just going to use the snippets. Then what we're going to do is plug those headlines and snippets using Bert to create a word embedding. We'll concatenate that embedding with a random embedding that's roughly twice as large. And that's going to soak up any remaining variation that Bert can't capture. And then we're going to re-aggregate those word embeddings back to a single vector for the entire thing using simple but tough to beat, which is from the ICLR paper from several years back. Very easy way to kind of tune your final step of the process. So you just take a weighted average by inverse term frequency and sample, and then you deflate it by essentially principal components analysis. So it works really well. So the thing that I would call out here is that we're creating hundreds and hundreds of different features for this thing to use. The amount of news that I'm actually observing, like I said, 500 feeds, 1 to 10 items a day, you know, a couple thousand on average. So this thing will massively, massively overfit. So the other predictors that we're going to add in are basically to prevent the model from putting that variation onto the content itself. So for example, the weekly news cycle effect, we can dummy code what day of the week it is very easily. And as long as they're allowed to interact with other things, they can start allow the model to kind of pick up on variation in structured ways. So for example, if we knew that football news was important on Sundays and Mondays, you know, if football items are coming in throughout the week, but only on the Sundays and Mondays, is it getting clicks? By having that interaction in place, the football content predictors will not get downweighted on the Tuesday through Saturday results. Same thing applies for like stock news. Monday through Friday is when the trading floor is open. Movie releases are only important on Fridays. So all of that is kind of on the table. As long as we include the day of week dummies and we're using a model that's flexible enough to pick up on those interactions, we get to soak that variance. And similarly, we can do annual trend effects. So the exact same intent as the weekly trend, but this is going to also allow it to pick up on that so-called relevancy decay. So for example, if we know that college basketball gets a lot of clicks during March for March Madness, as soon as this thing crosses over to April, the model will be able to put the after April college basketball content and downweight it. This also works pretty good for holidays and elections. Elections being important this year. Hopefully another month and I won't have to see any of those news items for another 4 years. So then I'll talk briefly about ranking effects. So there is this kind of positional effect when you're looking through news items where, you know, the top ranked item will draw proportionally more of the clicks just because it's, you know, front and center. And then there's kind of a decay as you go down the list. So we can incorporate that, works pretty well. And finally, redundancy effects are the last kind of piece of this puzzle. So within a day, if something happens in the world where you get lots and lots of news about it. So the pandemic is a good example where it showed up on 300 feeds all at once. Later items in your list of news with same or similar content are less likely to get clicked because there are those clicks on the earlier items. They're not showing new news, they're showing the same news. But we don't want the model to observe that and downweight those content predictors. So what we can do is we can calculate the cosine similarity matrix of all the items that are getting displayed. And just a quick reminder, that will be a 1 if the items are exactly duplicate and a 0 if they're completely different. And then we can take the column max of the upper triangle and use that as a predictor, and that will pick up on, in this case, a negative association between those items. Which takes us to our actual model now that we've created all these predictors that we can use. So currently I'm using XGBoost. It's pretty much industry standard at this point for 2 reasons. So one, it can easily capture variation with multi-way interactions. The deeper the tree you allow it to build out, the more interactions it can potentially pick up on. And secondly, because it is very fast, it can run on a GPU. It can do parallelized cross-validation. It's very well-designed software, in my opinion. And then second part of that is you do need to do a lot of hyperparameter tuning. So I'm using HyperOpt, which was one of the earlier hyperparameter tuning packages in Python that came out several years ago. Still works great. It lets you provide custom loss functions so you can integrate with, for example, the built-in parallelized cross-validation. One of the interesting things is when I've built these systems before, usually you want to warm start your retrain so that you're not researching the entire grid. For whatever reason, news doesn't seem to benefit from warm starts on your hyperparameter tuning. So just a little interesting aside there. And then another thing that ends up being pretty important is how often do you retrain? So news comes in every single day, and the performance of these models is very, very sensitive to model decay and the width of the training set window. On the other hand, retraining these things is also expensive, so you don't want to do it too much. So you can kind of empirically trade this off based on how much you're spending on Amazon or how well you're seeing it perform in production. So my current plan right now is to retrain every Monday using the past 30 days. So that seems like a decent split by that. This whole system ends up costing about $20 on Amazon per month. So it's very, very affordable. Another thing that's kind of tricky is the cold start and overfit problem. So there's two problems that are kind of two sides of the same coin, in my opinion. So brand new topics can't score high until they've built up a history of clicks. So this is a cold start problem. And then the other side of it is that things that got a lot of clicks in the past are going to stay ranking high, in this case, potentially for a whole week before that retrain cycle kicks in. And that can make it just miss the relevancy decay. It'll promote older items instead of the new ones. So one solution to that is to run a greedy epsilon bandit on the item level on top of this whole thing. So in this case, our greedy is our model, and the epsilon would just be a random placement so that it can kind of break that cycle. So this is just going back to talk about the system architecture. Again, runs on 3 services on Amazon, so it's very simple. And again, because of that, it's cheap. So we can do the actual news aggregation in AWS Lambda, can use S3 for the storage and SageMaker for the training and the scoring. And then I'll just mention some future things I'd like to expand upon in the, so one is to downweight known bad feeds or sources. I do see a little bit of like SEO spam in these things. Like the model scores it down immediately, which is good, but I'd like just rather not have it in there to begin with. I'd also like to spend some time tuning the simple but tough to beat weighting parameters. The reason that that's not happening right now is because it changes the design matrix, which would be a bit more computationally intensive. I'd also like to experiment with iterative rescoring so that like the model could find combinations of items, for example, instead of just a single dimensional highest score to lowest score fit. And then I'd also like to explore some batch boosting because I think that could improve it quite a bit. Okay, so we're right at 20 minutes, which is about right. So we'll just go back through the summary again. So timely and relevant news is key for businesses and people to stay informed. Although there are similarities with search, we can do better by modeling the news process. And I think that's a very, very quick run through of why I think news is hard. So I'll close this out with this great line from Stranger in a Strange Land. So most neuroses and some psychoses can be traced to the unnecessary and unhealthy habit of the daily wallowing in the troubles and sins of 5 billion strangers. This was written in the 70s, 60s maybe. So we're probably closer to 10 billion at that point. And if you have a good news aggregator, it can filter out some of those unnecessary and unhealthy news items so that you can focus on only the ones that are truly important. And with that, we can go to questions. So I will give people a minute to type questions in the chat. And otherwise, I always write my own. So who am I? I kind of skipped this little intro thing at the beginning because I feel like the content is kind of the most important thing, but I will give you a little background. So I run a boutique consultancy for machine learning for the credit, marketing, and systems spaces. I am an open source developer. There's my GitHub if you're curious. I'm an occasional bootcamp mentor, startup advisor, etc. I think there's probably a couple of my mentees on the call. I don't know. And this is actually my 5th ideas talk. So I gave one at USC, and then another one in Pasadena, and then I think 2 in downtown. So those talks are also posted on my personal website if you're curious. All right, so we got a couple questions. Okay, so I got a hello from John Fries. What's up, man? Let's see. So what else? Should you use the Google Colab for free? You know, the last time I used Google Colab, I really liked it because they had kind of a multi-user Jupyter Notebook style thing. And then I went away for a couple months and that feature was gone. So I haven't spent as much time on the Google stack as the Amazon stack. But I do remember liking Colab specifically for that feature, and I hope it comes back. Let's see, what else? How will the field of cybersecurity as more companies build on top of the cloud? How will the, okay, so that's probably like how will the field of cybersecurity adapt as more companies are building on top of the cloud? I mean, hopefully we're okay. Like there's always kind of a fear or risk that as you're building on top of different platforms that it's shakier and shakier until the whole thing collapses. But I don't think we've hit that point yet. Let's see what else. Let's see, personalized news recommendation is quite different from product recommendation for e-commerce, in my opinion. What would you do to reduce confirmation bias, especially when the news is fake? Yeah, so fake news is, I mean, I kind of think of it as more similar to like advertising, right? Because they're really just trying to get you to click it and market their ideas to you instead of presenting something that's objectively true. So definitely there is this problem where those things are the clickiest. And so you need some way to kind of break that feedback loop. Otherwise, it's just going to get into your click model and kind of dominate there. Okay, so I'm going to dismiss that one. Oh, so one other question. So my company is called NJM Consulting, NJM. I just chose that because it was a short domain name that was available. Currently, I'm ranked second on Google, right behind the New Jersey Naval Museum. So there's that. So people also ask me, am I hiring? I'm not, because I'm a one-person business, but I do know some companies that are. You can contact me or connect on LinkedIn after the talk if you're interested. Okay, let's see. What's your prior for an article being interesting? So the way that this system is set up, like, I won't add a feed if I think it's not going to be interesting ever, right? So each of those 500 feeds has like at least some kind of prior weight given to it of it being a good feed. So yeah, but this isn't designed with any Bayesian methodology in mind at all. It's very much a machine learning, like get the data out into a matrix, score it. Hopefully that's better than not doing anything. Let's see. Another person asked, what's the cost for AWS per month? So the Lambda functions cost about $2. And then the S3 is less than $1. And then the SageMaker costs break out to about 50 cents per day, and then another couple dollars per retrain. So very affordable. Okay, do other people have questions? Okay, well, I wrote a couple more. Be thinking of questions, because your questions are better than my questions. So let's go to the next one. So is there other related work? So I'd also really call out the Naver presentations from AI and social sciences last February. Naver is a news app in Korea. I was not familiar with it at all, but it was pretty cool to see that they were doing kind of similar things as I was. They have a much larger user base than I do, and many more feeds, much more sophisticated UI. So it was really interesting to see them doing a similar thing. They were using a different word embedding for their language, but then they were stacking it into XGBoost, and it was still working really well for them. let's see. Okay, and so why does Bert work was another question I'd kind of planned on seeing. From Google's paper, there's this diagram that might be a little small, but generally Bert's trick is that it uses the context from the entire phrase instead of just kind of one token in sequence. So if you have the phrase Teenage Mutant Ninja Turtle, the embedding for teenage can be influenced by the later words. That's their explanation of why it works pretty well. Any other questions?
Hey Neil, this is a Jason. Thank you to be our speaker again.
Yeah.
I congratulations on your work. It's my first time to hear about the news, the system to build a news filter. Okay, so when you were working on the project, so can you give us some a little bit about the details about the algorithm running in the backend?
Sure. Which part of it? Like the news aggregation side of it, or the okay. Yeah. So basically, I have a set of Lambda functions, and these are kind of like little snippets of code that Amazon will run on their server for you that extract data from different types of feeds. So the most common feeds that I encounter are so email feeds. There's a lot of like enterprise systems that will not necessarily expose their data in a machine readable way, but they will send you update emails whenever something changes. So for example, like the procurement systems for the state of California, whenever they post an RFP, it can get an email notification. So that's one. Another common type of feed are RSS feeds. Those are very like early 2000s Web 2.0. So those are very easy to work with. And then there are some JSON feeds also, which are kind of isomorphic to the RSS in my opinion. So I'm not doing any like super intensive like web crawling or anything like that.
Okay. Thank you for your comments on my question. So
wait. So I got a great question in there. So what about GPT-3? So I actually prepped that one. So why am I not using GPT-3? So that's API only right now. So that is the exact reason why I'm not using it, is because it doesn't integrate in with the rest of the system as I built it. So thank you for that question.
I have one follow-up question about the GPT-3. Today, another speaker mentioned that, I remember in the morning, but from my understanding, GPT-3, compared with Bert, GPT-3 is a public, API. I have some friends, they are the first, group of people who can, it's called a pilot, a user to use the API. They built a, bunch of applications on the top of GPT-3. But my feeling is, it's like a NLP, huge NLP application. It's a lot of, knowledge in the database, but the application is just built on the top of the knowledge. It's not it's not creation. It's something like a combination. So what is your point, to build the app using GPT-3?
I mean, so I'm essentially using Bert as a black box as well. So I think that, at some level, you're always going to be treating your tools and packages as a black box. But, I would also agree that what they're doing is aggregating a bunch of data and making something very, very large. That seems to be like its primary innovation on top of the last generation's GPT-2, is they just made it a lot larger, which is fine. It seems like it works really well for the people that have been able to beta test it out. So yeah, I would agree with those sentiments generally, I guess. For this particular application, I do want to host it and run it myself. So that kind of rules out using a third-party service like that for scoring individual items. Like this thing is very much motivated by kind of a batch system where it can score all the news, you know, can load it onto the GPU once, score everything, and get the results out and push them. So it's not as well set up for like calling an API every time there's a news item or something like that. So
yeah. So what is your plan for next step?
Sorry, what was that?
What is your plan for next step?
Next
Maybe
step?
in, yeah, I'm not talking about 3 or 5 years, maybe just 6 months.
Okay, yeah, so I definitely need to expand the number of feeds that are in there. So those have been, you know, personally curated over the last 2 years. I feel like as I kind of build out the system and get more and more feeds into it, it'll shift how it fits, and that'll probably bring up even newer issues that I'll have to deal with. So let's see. So there's a YF Chen in the chat, and he says, "Hi Neal, thank you for a great talk. I have 2 questions." Okay, so we'll do them one at a time. So 1, what do you think of the personalized news feeds provided by big companies such as Google News and Microsoft News, news briefings in the Samsung cell phone, etc.? So I actually have some feeds coming straight out of Google News and Microsoft News and plugging that into my system and rescoring and re-aggregating them. So I feel like, at least for myself and my users, my system is doing better than those. But they're good products and they're useful. I would be curious, like, since I don't know exactly what they're doing under the hood, what kind of objective function they're trying to optimize for. If it's Google, maybe they're trying to optimize news for ad clicks instead of news relevancy. I don't know, but that would be a concern. Okay, and then the second question is, how is your method different from the ones of big tech companies? And so I would say it's not necessarily different. So like I said before, Naver is using a very similar strategy. So I think you know, kind of the double embedding to sentence embedding mapping is a little unusual, but the general idea is not different, right? It's just something I built for my own business that works well for me. And hopefully people can kind of take this talk and try it out with their own news feeds. You know, the whole thing is open source. It's on GitHub if you're particularly interested. But it's, again, a lot of the components are kind of out there and available already. So this is like a good project if it's something you're interested in. It's a nice intersection of some of the stuff going on in natural language processing, some of the stuff going on in industry like ad tech and click modeling and stuff like that.